Okay, first of all, I want to thank you all for inviting me to share this work today. Because this is pre-recorded, I welcome any comments or questions you all might have via email. My email is there on the slide. I would definitely welcome any feedback you all might have. So today I'm going to talk about disentangling climate and human influences on lakes in China using a multi-proxy approach. Like many of you, I am really interested in the intersection of humans, climate, and the environment. And the central question that I have been really interested in for a long time is, in regions where you have a long history of intense human occupation, how do you separate out these three influences? And as we all know, there's lots of global locations where we can ask these questions, but I was particularly drawn to Yunnan because it has a rich archaeological and historical record to draw on. And it is also influenced by two monsoon systems, right? So the Indian summer monsoon and the East Asian summer monsoon. So climatically, it's quite interesting. Yunnan also has abundant lakes to study, right? So there's lots to choose from. Kunming, up here in the top of the map, of course, is on the shores of Lake Dion. And then as you move south, Fushan, Xinyun, Qilu, and Yilong. Right, so and all of these are tectonic basins, so many of them have very long records of sedimentation. Many of these lakes we also know are eutrophic. They suffer from nutrient loading issues. So you can see that in some of the pictures that I've posted on this slide. All of them have rice agriculture in their catchments. So we know that they're impacted by human activities today, which make them really interesting to study because we can compare those present day human activities to the past. The work that I'm going to share with you today is going to focus on Dian, Xinyun, Qilu, and Yilong. But as I mentioned, there are abundant other lakes to study that many other Chinese and American scientists have focused on. There has been some other previous research into Yunnan lakes, particularly in the 1990s. One particularly well-known example is that of Dave Hodel and others. And so in this paper from 1999, they looked at lakes Xinyun and Qilu, collected many meters of sediment and measured, in particular, oxygen isotopes, which I'll get into more in a minute. But at both Xinyun and Qilu, what you can see is that over the Holocene, we have this long gradual decline in monsoon strength, which is pretty well expected at this point. Most records have documented that. But what caught my attention when I first read this paper is that at both of these lakes, there are some really abrupt jumps in these oxygen isotopes. So at Xinyun, you can see there's one here at about 3,000 years BP, and then another one at about 1,600 years BP. And at Qilu, well, really just the last 4,000 years, the oxygen isotopes are all over the place. And so what caught my attention about this is, well, is that something to do with some sort of tipping point with monsoonal climate, or is it human activities? So approaching this project, there were three main research questions I had. The first, what impact did Holocene monsoon variability have on lake hydrologic balance over centennial and multi-decadal scales? I'm not going to focus on that today for this talk, right? Because we're more interested for the purposes of this workshop in the second two questions. What is the nature and timing of human impacts prior to the 20th century? And what is the relationship between hydrologic balance and human activities? So to do this, as I mentioned, I'm going to use a multi-proxy approach. One of the first ways that I'm going to address this question, though, is similar to what Dave Hodel and others did, which is looking at stable oxygen isotopes. I'm not going to go through these in great detail. I expect many of you are probably relatively familiar with these methods. And in the interests of time, I'm not going to review all of it, but I will just highlight a few key concepts for the purposes of understanding our records. Usually we are looking at oxygen isotopes in relation to a standard. One of those would be standard mean ocean water, which is set at 0. And when we have our cloud that evaporates from that ocean water, and as it moves inland, particularly associated with monsoonal summer precipitation, it has a mixture of water molecules that are made up of mostly oxygen 16, but some oxygen 18, much less common. As that cloud moves further away from its original source of ocean water, the small amount of water molecules that might have oxygen 18 in them, because they're slightly heavier than oxygen 16, these molecules tend to fall out first. Right? And so if you look at precipitation associated with monsoonal rains, what you would see is that you have fairly negative delta 18O values because you've lost a lot of oxygen 18 in relation to oxygen 16. And so precipitation in Kunming then is fairly negative in relation to ocean water, with our most negative values occurring during those summer months of monsoonal precipitation. Now, in lakes in Yunnan, many lakes in Yunnan, not all, but many of them, we precipitate carbonate minerals, especially calcite. There are some other carbonate minerals that are precipitating in these lakes, but calcite is usually the dominant one. And the oxygen isotopic composition of that calcite, when it forms in the summer and falls to the bottom of the lake, that is archiving the oxygen isotopic composition of the lake water. Right, which is in part in the summer especially influenced by this monsoonal precipitation, all of those upstream air mass processes that have caused all of that oxygen 18 to fall out. Okay. Now, additionally, in Yunnan lakes, many of them function as closed basins, meaning they have minimal outflow, and in fact, the primary mechanism of water loss is through evaporation. And that plays an additional control on influencing oxygen isotopes in our lake water, right? Because if we have evaporation occurring, oxygen 16 will be preferentially evaporated over oxygen 18. So now when our carbonate minerals get precipitated in the summer, relative to when we had less evaporation occurring, we get more positive delta 18O values when that calcite actually precipitates. Right, so in closed basin lakes then, which many Yunnan lakes are, we have the oxygen isotopes are really reflecting both precipitation and evaporation, P and E balance. And so this makes them particularly sensitive to changes in hydrologic balance. If we examine the oxygen isotopic composition of these carbonate minerals back through time, then we have in a way to effectively reconstruct lake levels, right? And that's due to both natural processes as well as human processes, as we'll see. Okay, so before I share with you some of the results of the oxygen isotopes, the one thing I want to note is that in the 4 lakes I'm talking about today, immediately when we pulled up these cores in the field, we noted that there is a prominent change in sedimentology in all of them. So they go from a gray, sometimes a brown, silty clay at the base. And then as you move closer and closer to present day, you get this gradual and diffuse transition to red, iron-rich, very fine-grained clay. And this change in sedimentology was noted by some other previous studies of Yunnan lakes, but it was unclear how widespread that was, and the timing was really uncertain. For this work, what we've been able to do is improve those age models, and we can now pinpoint the timing of the deposition of this clay layer. And so it occurs at about 2,000 years BP at Lake Dion, 1,500 years BP at Shinyun and Chilu, and 700 years BP at Yilong. We can also see this prominent change in sedimentology reflected in the magnetic susceptibility values. So Lake Dion, we have 2 cores from both the north and the south, Xinyun, Qilu, and then Yilong is actually still in progress. This is very new work that we're still working on. But what you could see from the other 3 lakes is that right when we have that change in sedimentology, we also have a rapid, really large increase in magnetic susceptibility, which demonstrates that that red clay layer is really rich in iron-bearing minerals. Other work by myself, as well as other researchers, which I don't have time to get into today, has shown that that really matches the color and composition of catchment soils. So this really represents some pretty profound soil erosion occurring at this time. Okay, so we move into the oxygen isotopes for those lakes that precipitate carbonate. I'm going to move from north to south. The solid line is the best age model representation, and then the shading around that is the 95% confidence intervals for the age models, so that you can see that many of the events I'm going to talk about occur synchronously, even when we take age model error into account. So Xinyun first, we see this gradual, nice declining trend through the Holocene that represents the waning of the monsoon. No surprise there. But notably, there are some several abrupt jumps in our oxygen isotopes. All right, more on that in a little bit. Qilu looks much the same, although we note that there's less variability in the last 1500 years. And Yilong also looks much the same, with, again, even less variability within the last 1500 years. Right, so if we look at these 3 lakes in a Holocene context, we can see that there are several common features: a decline followed by a period of stability, followed by another lake level decline. What's going on through the Holocene is a whole other talk, but I wanted to display the Holocene records so that you can see the scope of what's going on in the last 1500 years is really quite anomalous, which is, of course, when we start to get all of our red clay layer from sediment erosion being deposited. Now, if we step back, we know that settlement occurred around many of these lakes somewhere between 4,000 and 3,000 years BP. There's nothing immediately obvious from these lake level curves that indicates human impacts, although I will note this period of stability that occurs is quite odd. We would expect, with continued declining summer insolation and a weakening monsoon, that would be reflected in those lake level curves, and it's not. We're exploring right now possibly natural mechanisms to explain that. Hopefully more on that in the coming years. But I should say we also can't really discount human-induced possibilities to explain that period of lake level stability. It's hard to imagine really large-scale impacts at this period that could explain that. But we do have some evidence of potentially nitrogen loading from sewage at Xinyun at this time. So we really can't discount human influence. And trying to sort this out is what we will be addressing in the coming years. What I will say for sure we know is that after 1500 years BP, we have historical records that terrace rice agriculture intensified. And this is really reflected in all of our lake level curves. And this is when lake level manipulations become really evident. So if we zoom in on the last 1500 years, the magnitude and abruptness of those changes becomes really quite apparent. And this is extremely evident for Xinyun. I've added in here the periods of the medieval climate anomaly and the Little Ice Age, which, according to past synthesis studies, are wet and dry respectively, to show for reference that maybe there's some influence of these climate periods on shaping lake level, but really they seems to be a minimal impact, because all 3 lakes are showing very different trends at each of those climate intervals, right? So it suggests climate is not playing this large scale control. Rather, it is indeed people. At Xinyun, we have historical records and indications of lake level manipulation, which match up very closely with our isotope record. So the construction of a dam for one, and then repeated trenching for another. At Qilu, we have fewer historical indications of lake level manipulations. Today, there's a dam that blocks outflow, makes the lake artificially higher, and we don't know when that blocking of that outflow commenced. We can make a guess that it might have occurred somewhere around 500 years BP based on that isotope record, that lake level curve, but we don't know for sure. And then at Yilong, we can see there's actually very little change. There are some minor isotope fluctuations, but really in comparison to Qilu and Shenyun, it's quite minimal. So what I suggest here is that we have a gradient of human impacts moving from north to south, and that the way these lakes were used in the last 1500 years or manipulated is really quite differing dramatically between the three lakes. Now, what about Lake Dion, for which carbonate minerals do not precipitate in a high enough abundance to perform isotopic analysis? And this is where we have to use some alternative methods to get at human impacts. Again, I'm not going to get into the details of this due to time, as well as probably most of you being familiar with these techniques. But at Dion, we're going to use carbon and nitrogen isotopes of organic matter. And there are lots of things that influence those two isotopic systems. But initially, our thought was, well, it's been pretty well established that for both carbon and nitrogen, when you have increasing primary productivity, those values shift to more positive values. And again, there's lots of other complicating factors, particularly for nitrogen. We know the influence of the human perturbation of the nitrogen cycle really fouls things up. But initially, that was what we were thinking with using these two isotopes. We can also pair carbon isotopes with carbon to nitrogen ratio, or C-N ratio. Because as we have increasing primary productivity, if algae become the dominant source of organic matter, then we should see carbon to nitrogen ratios decline due to this separation between lacustrine organic matter and terrestrial organic matter. Okay, so for Lake Dion, again, we have two cores, one from the north and one from the south, since it's a really large lake. And the record of Dion is quite old. I've cut it at 4,000 years BP so that we can really focus on those post-settlement impacts. Again, at that settlement period between 4,000 and 3,000 years BP, we don't see really any obvious indicators of impacts, at least as captured by these particular proxies. What we do see is that at about 2,000 years BP, when we know we have that sediment erosion occurring, we do see that this had impacts on nutrient cycling. So we have a trend towards increasing primary productivity, as indicated by our carbon isotopes getting less negative and our C-in ratios declining. So I would posit that this is really due to sediment erosion, lots of nutrients washing in and likely driving this increasing primary productivity. And this does appear to be evident at both the north and the south ends of the lake, although perhaps more prominent in the north end closer to Kunming, which makes sense. And then nitrogen isotopes actually increase quite a bit later at about 600 years BP, which I would almost certainly attribute to the influence of things like sewage, given the levels that they reach up in the uppermost sediments of 12 per mil, which are quite exceedingly high. So to sum up, I think what we see at Yunnan Lakes is a gradient of human impacts. We definitely see that over the last 2,000 years, human activity is the primary driver of change, but that change is manifested differently at each of those lakes, slightly differently. Earlier human impacts, I would say we can't completely discount them. This is an area of research we probably need to use more innovative proxies, perhaps organic geochemical proxies, to really definitively tie down this initiation of human activity. It does become quite ambiguous the further back you go in time. But what's clear from our lakes where we have a lake hydrologic balance, a lake level curve, is that after 1,500 years, each lake was altered in a different way, and it becomes very difficult to attribute any of that to a climatic overprint, right? It really becomes a human-dominated system. Lastly, I would emphasize that a multi-proxy approach is really key. It's only through using lots of different proxies, working together with many Chinese and American scientists, each of us having our own skill sets, that we've really been able to unravel this work. This represents, a decade more of work with using lots of different proxies and lots of different approaches. So I think that's a really key thing for us to remember as we move forward. Lastly, I'd like to thank my many co-authors, both American and Chinese, again, as well as several graduate students who've been involved in this work. And my sponsors as well, National Science Foundation, as well as the National Science Foundation of China.